All right. Do broadcast messages work to breakout rooms, by the way? If I broadcast a message, you see it, it comes through. Okay, good. All right. So let's go back to the function here. We'll go back to my whiteboard. Ladies, first one is A or F a subset of A cross B. Somebody, you were supposed to come up with spokesperson, whoever you want it to be. Lauren, yes. Is F a subset of A cross B?
No, because the grouping for, or the ordered pair, I should say, for E is not, it does not exist in A cross B.
Correct. Yep. So case number 0, 4E does not live in A cross B, and so therefore F is not a subset of A cross B. Cool. All right, guys, hypothesis number 1. Every element from A appears in an ordered pair. What do we got there?
False, because element A equals 5 does not exist in F.
Yep, so element A equals 5 does not appear as an ordered pair. Good. All right. Ladies, last one. If two first values are the same, then the two second values are the same. Yes or no? What do we got for this one?
We said no because for the A being 1, B1 is A and B2 is B, and those are not the same.
Yep, so we would say 1 comma A and 1 comma B have the same first component, but A does not equal B. So they don't have the same second component. And you could say that a whole bunch of different ways. I just kind of summarized it for this one. So 1 comma A and 1 comma B have the same first component, but A is not equal to B. Okay, so this is one way to define a function. Yes, we're good with writing it out as a set of ordered pairs. Everybody good? Okay, it is not going to scale up well, right? This is definitely not going to scale up well. 5 ordered pairs is okay, but, ooh, there goes my pen. This is not going to scale up well. Next one we want to look at is an arrow diagram. Also not going to scale up well, but it's something that we should talk about. So way number 2 to define this is an arrow diagram. We won't spend a ton of time on this because this one is basically the same thing as a set of ordered pairs. You're just representing it in a different way. So let's stick with our same sets. A is still 1, 2, 3, 4, 5, and B is still A, B, C, D. Same sets here. So an arrow diagram can get drawn one of 2 ways. You can either go from left to right or from top to bottom. It doesn't matter. I will go left to right, but you could do top to bottom also. So we will do 1, 2, 3, 4, 5. We'll do A, B, C, D, and then we'll draw some arrows in. The 3 requirements: you need to have subset, right? So I can't have an arrow. My arrows are going to go from left to right. I can't have an arrow going to something that is not in this list on the right, correct? That's the first thing, subset. The second thing is that I have to have an arrow coming off of every single element over here on the left. Every element has to appear as the first component in an ordered pair. And the third thing is I can only have 1 arrow coming off of every element over here. I can't have an arrow coming from 1 to A and from 1 to B. That's going to violate the third one. So maybe we'll draw some arrows. We'll go like this and like this. We'll go here. Maybe we'll go here, and then we'll take 5 up to here. So 1 and 2 both point to A. 3 and 5 both point to B, and 4 points to C. And again, if you want, you can do this so that 1, 2, 3, 4, 5 are on the top, A, B, C, D are aligned down, and then your arrows can go from top to bottom. Either way, doesn't make a difference whether you go sideways or top to bottom. So for this one, usually we write the F in the middle because F is what is being represented by the arrows. You can put F anywhere you want. You could put it on the left or put it on the right. Usually I'll throw it in the middle, or if I were going from top to bottom, I would kind of put it on the side. But in this case, we can go immediately back to a set of ordered pairs. So 1 comma A, 2 comma A, 3 comma B, 4, comma C, 5, comma B. One A, 2A, 3B, 4C, 5B. Clear? Arrow diagrams are not super interesting, but I want to draw them for you so you know what's going on. Everybody got an arrow diagram? Everybody happy? Okay. All right. Third way is the one that you're more familiar with, and this is the one that gets used way more often. But my third possibility is defining F using a rule. Defining F using a rule. For example, let's say that we had the one that was in your reading assignment. F goes from the integers to the integers, and I am going to take an element X and send it to the absolute value of X. So again, remember, this is my notation. I don't think the arrow with the head in it is going to show up in the book, but I really like this notation, so I'm going to use it, plus for a lot of future math classes. So F goes from the integers to the integers, and the X element goes to the absolute value of X. Let's do a couple of for examples. So I can do a couple of F ordered pairs. I can't write them all out because integers are an infinite set, but I can say that, for example, F of 1 is equal to the absolute value of 1, which is 1. 1 was a bad choice because you got absolute value bars, but you know what's going on. F of -5 is the absolute value of -5, which is equal to 5. So I can have some ordered pairs in here. This one is a rule. Everybody good? Making sense on a rule? All right, what's my domain? This one's easy. Domain is equal to, Grant?
The integers?
Yes, and which integers? The first one here or the second one here? First one or second one?
First one.
Yes, the domain is the integers because that's the first one. All right, Grant, keep going. Codomain?
The integers again.
Yep, and that's because of the second one here. So my codomain is the integers because of the second one. All right, range is the harder one. So what's my range? What are all actual outputs? Range in this case. What's my range gonna be?
The absolute value of X.
So that's not a set. That would be how that helps you in figuring out the range. Absolute value of X absolutely helps you out. I can write it that way, actually. So range is going to be the absolute value of X so that X is an integer. We could write it that way. That would be possible. That doesn't give me any additional information beyond what I have. So that's not wrong, but it's also not super helpful. Do we have a little more helpful for what my range is going to be in this case? Grace, what do you got?
The positive integers.
So close. Positive integers, we're missing something. What are we missing?
Is 0 part of it?
0. So we want to write the positive integers, and then I'm going to say union the element 0. And since I'm doing union, I have to make 0 into a set. Right? I can't just have 0 by itself. I can't do a union of a set and an element. I got to make 0 into a set. So positive integers union 0. Yes, good. Grace, question.
Is 0 not an integer?
0 is an integer. 0 is not a positive integer.
I thought it was because, oh wait, never mind. I'm thinking even. Never mind.
Yes, 0 is even. Totally true. So 0 is neither positive nor negative, but it is an integer.
Yeah.
Yes.
Never mind.
You're good. Other questions? Other ones here? Does it make sense why range is harder to find? Yes. Yes. Range is harder to find here. Okay. Couple more. Well, one more example, couple more definitions, and then we will be good to go for today. So